All right, so this is where it's going to get just a little tricky with the what's called dependent events. That is where what happens in your first event affects directly what could happen in your second event, such as the example: fan out a deck of cards, pick a card, any card. Well, if I had you pick a card and then I went to the person next to you when they pick a card, if you don't put yours back, the number of cards in the deck has changed when they go to choose. So 52 cards in a deck. If you pick one, when they go to pick one, there's only 51. And if I went down to the next person, there's only 50 and 49 and so on and so on. So the denominator of our fractions is going to change every single time if it is a dependent event. And depending exactly on what I'm asking you to do, the numerator could change too. Okay. Overall, try and keep this simple in your head. Like, what am I actually being asked to do? Am I drawing a heart? Am I pulling a red marble? Don't overthink these and try and do one event at a time. And then at the end, we'll multiply it all together. Okay. The first event always affects the second event. The second event always affects the third event, and so on and so on and so on. With what we're doing today, what we did before when the events were independent of one another, it didn't matter. What happened the first time did not affect the second time, and so on and so on. So what we're looking for is something called replacement. Okay, we're looking for replacement. If we're putting the cards back, if we're putting the marbles back, okay. So you'll have to read into these a little bit, like if we were to have a test or quiz or something, and things were jumbled up. But I've tried to keep these kind of compartmentalized until now. Okay, so here's our bag of marbles that we've dealt with, pretty much every time we've talked about these. There's 20 marbles in here. There's 5 greens. I'll even write that out. There's 5 greens. There's 9 red and 6 blue. Okay, 20 altogether. So what we're going to do is reach into this bag and pull out a blue marble. So that is going to give us 6 out of 20. No problem. However, we're not going to put that blue marble back in the bag. So when I reach in the second time to try and pull out a red marble, there's not 20 marbles in the bag, there's only 19. So for that one, there is 9 reds out of 19 instead of out of 20. When I go multiply these together straight across, that's 54 out of 380. Yep, 380. Again, I want these reduced. So you either need to reduce these on a calculator, or like I told you earlier, you can go back and reduce them before you multiply. So that 6/20ths can be turned into 3/10. So this would be 27/190. Okay, that's your probability. You've got 27 out of 190 times that you'll be able to pull out a blue than a red. Okay, I want to skip the double red and come back to it because that one's a little bit different in and of itself. So let's do the not blue. So we're going to reach in and pull out a not blue, which there's 14 of those guys. Okay, now I want to reach in and pull out the blue that I skipped the first time. So again, there's 19 marbles that second time around. I hope that makes sense. You're not putting the first one back. So then when I reach in and pull out my blue, 6 out of 20 on that, 6 out of 19 on that one. Reduce before I multiply. So that is 42 over 190. That'll reduce again because they're both even. 21 out of 95. Now, the double red, that one it's kind of a double-edged sword because you're reaching and pulling out a red, reaching and pulling out a red again. This time, again, it's 2019, just like the other ones were. However, if we reach in and pull out a red that first time, there's 9 reds, so that one shouldn't be a problem. If we were successful, if we pulled out that red the first time, when we reach in there and pull out another one, there's not 9 reds anymore. There's only 8. Okay, so if you are repeatedly performing the same task, like pulling out a red, pulling out a red, pulling out a red, the number of reds in the bag is going to change as well as the number of marbles in the bag. Okay. So let's see. 20 and 8, that's 4 and 10. And go down again, that's 2 and 5. So that is 18 out of 95. Okay. Those are tricky. Those are the ones you're really going to have to watch out for. If it's two completely separate events, like the blue and a red, or a not blue than a blue, where they don't overlap, those are a whole lot more straightforward. If you're trying to double dip and do the same thing over and over again, that's definitely going to change what you're doing. Okay. A deck of cards. Okay, so we kind of already hinted at this. So the first time we reach into that deck, we get 52. The second time we're going to reach in, there's not 52, there's only 51. Okay, so I want to reach into this deck and I want to see what's the probability that I can pull out a red and then a black, in that order, red, then black. So if I reach in and pull out a red, that's hearts and diamonds, there's 26. And then I reach in and pull out a black, spades and clubs, also 26. However, the second time there's only 51 cards in the deck. I'm gonna be lazy on this one. 26 times 26, 676. And then 52 times 51, 2,652. If I were you, I would try and use my calculator to reduce my fractions here. That goes down to 13 out of 51. That's almost a 1 in 4 chance of being able to do that. Okay, reaching in and pulling out 2 reds in a row. So this is similar to the marbles that we just did. I've got 2 in a row of the same thing. So the first time I reach into that deck, I'm going to pull out a red. That is 26 out of 52. If I was successful, right, if I pulled out a heart or if I pulled out a diamond, the next time around there's not 26 cards in that deck and there's not 52 cards in the deck either. There's only 25 out of 51. I'm going to cheat again. 650 for my numerator. 2652 for my denominator again. $25 out of 102. Okay. Hopefully the 52-51 thing here is making sense. All right, reach in and pull out a heart. How many hearts are in the deck? The first time around, there's 13. The second time, there's only 12 because I'm doing the same thing. Okay, if I did a heart then a spade, that's completely different. And that would be 13, 13. So 13 times 12, 156. Denominator staying the same, 2652. It goes down to 117. Okay, take your time on these. All right, I'm gonna have a lot of forgiveness for you guys on these because it's kind of new. It's definitely weird. You know, I'll let you redo assignments if we need to on this one because I want you guys to be successful at it.